Hello friends, I welcome you in lecture number 34 on graph theory. In this lecture we are going to understand the definition of m-ary tree and binary tree. So before going for this definition, we recall about the internal vertices. If you have seen previous lecture, then in previous lecture we have understood the definition of rooted tree. A rooted tree is a tree in which one vertex has been designated as a root and remaining vertices are directed away from that root. And in rooted tree, we have seen the definition of parent and child. If two vertices are adjacent, then one vertex is a parent and another vertex is a child, and the vertex which is closer to the root is called a child. And we have also understood the definition of internal vertex. Internal vertex is that vertex that has at least one child, or internal vertices are those vertices having at least one child. So using that definition of internal vertex, we can define m-ary tree, where m is a natural number or positive integer. So we understand the definition of m-ary tree with the help of this rooted tree. I am considering one rooted tree here. Suppose I have this rooted tree in which this vertex I consider as root, and I am having this type of vertices below this. Suppose I have one vertex here. Suppose I have two vertices, and suppose I have two vertices here. So now we can see, if we label all these vertices, suppose this is denoted by V1, suppose this is V2, V3, V4, this is V5, V6, V7, V8 and V9 and V10. Suppose this is a rooted tree in which V1 is the root. Now first we identify what are the internal vertices of this rooted tree. So we know that internal vertex is that vertex which has at least one child. So V1 has three children, V2, V3 and V4. Therefore V1 is an internal vertex. Similarly V2 is also an internal vertex because it is having a child. V3 is also an internal vertex because it has three children, and V4 is also an internal vertex and it is having two children. So we can see that V1 is an internal vertex having 1, 2 and 3 children. V2 is an internal vertex having one child. V3 has 3 children and V4 has 2 children. And all these vertices are internal vertices. These vertices are not internal vertices because they are not having any children. So now we can observe that every internal vertex of this rooted tree has at most 3 children, or every internal vertex has no more than 3 children. Every internal vertex in this rooted tree has no more than 3 children. In other words, every internal vertex in this rooted tree has at most 3 children. So we can say that this is three-ary tree. That is the meaning of three-ary tree. A rooted tree is called three-ary tree if every internal vertex has at most 3 children. So in general, for m-ary tree, the definition is that a rooted tree is called m-ary tree if every internal vertex has at most m children, or every internal vertex has no more than m children. That is the definition of m-ary tree. Again I repeat, in a rooted tree, if every internal vertex has at most m children, where m is a positive integer, then that rooted tree is called m-ary children. At most m children means it cannot have more than m children. And if every internal vertex has exactly m children, if every internal vertex has exactly m children, then we will call that rooted tree as full m-ary tree. If there are exactly m children for every internal vertex of a rooted tree, then that rooted tree is called full m-ary tree. And for particular value of m, that is for m equal to 2, we say that rooted tree is a binary tree. And if there are exactly m children for every internal vertex, then we say that rooted tree is a full binary tree. So that is the simple definition of this m-ary tree as well as binary tree that I have written here. A rooted tree is called an m-ary tree if every internal vertex has no more than m children, or we can write that if every internal vertex has at most m children. And the tree is called a full m-ary tree if every internal vertex has exactly m children. An m-ary tree with m equal to 2 is called a binary tree, and if we have exactly 2 children for every internal vertex, then we say that rooted tree is a full binary tree. So they ask you to write down the definition sometimes, and you can decide the given rooted tree is a m-ary tree for some value of m or not. Here I have taken 4 rooted trees, and we will check that whether they are m-ary tree or not for some value of m. So first we check for this T1. So what are the internal vertices of this rooted tree T1? So we can say that V1 is an internal vertex and it has 2 children. Then V2 is also an internal vertex and it has also 2 children. V3 is not having any children, so V3 is not an internal vertex. Then V4 is also not having any children, so V4 is also not internal vertex. V5 has 2 children, therefore V5 is an internal vertex and it has 2 children. So there are 3 internal vertices, V1, V2 and V5, and V3 and V4 are not having any children, so they are not internal vertices. And every internal vertex has exactly 2 children here, so therefore we can say that this is binary tree, and because there are exactly 2 children for every internal vertex, we say that this is a full binary tree, or another word is complete binary tree. So a full binary tree is that rooted tree in which every internal vertex has exactly 2 children, and here every internal vertex has exactly 2 children, therefore this rooted tree T1 is a full binary tree. Now we check for T2. First we find out internal vertices and their children. So we start with V1. V1 is an internal vertex. It has V2, V3 and V4. V1 has 3 children. Then V2 is also an internal vertex having V5, V6, V7. There are 3 children for V2 also, and we can observe that V3 also has 3 children V4 is not an internal vertex, it has no children. And here V6 is also having 3 children, V11, V12 and V3. So there are 4 internal vertices and each internal vertex has exactly 3 children for this rooted tree. Therefore, this T2 is a full 3-ary tree. If there are exactly m children for internal vertices of a given rooted tree, then we say that it is full m-ary tree. Here m equal to 3. So this T2 is a full 3-ary tree. Similarly, we can check for T3. For T3, if we observe, V1 is an internal vertex. It has 2 children, V2 and V3. What about V2? V2 has 3 children, V4, V5, V6. V3 also has 3 children, V7, V8 and V9. V4 has no children, therefore V4 is not an internal vertex. V5 has 2 children. V6 is not an internal vertex, it has no children. And similarly V7, V8, V9 are also not having any children, therefore they are not internal vertices. And here we can see that all these are internal vertices and maximum value of children is 3. So all the vertices are having at most 3 children for this rooted tree T3. Therefore this is a 3-ary tree. But it is not full 3-ary tree like this, because some internal vertices are having less than 3 children. So it is full 3-ary tree if every internal vertex has exactly 3 children. But here all the internal vertices are not having exactly 3 children, but they are having at most 3 children. Therefore this is a 3-ary tree. And this is another example. T4 is a rooted tree, and we can count the vertices children for internal vertices. V1 is having V2, V3, V4, V5 and V6, that is 1, 2, 3, 4 and 5 children. V2 is not an internal vertex, it is not having any children. V3 has 1, 2, 3, 4, 5. So V3 is an internal vertex having 5 children. V4 and V5 are not having any children, therefore they are not internal vertices. V6 has 1, 2, 3, 4, 5 children, and this V7 to V16 are not internal vertices. So there are only 3 internal vertices, and all the vertices have exactly 5 children. Therefore this is full 5-ary tree. So this is very easy concept of m-ary tree and binary tree. We conclude this session by again repeating this definition. A rooted tree is called an m-ary tree if every internal vertex has no more than m children, and the tree is called a full m-ary tree if every internal vertex has exactly m children. And m-ary tree with m equal to 2 is called a binary tree, or in other words, a rooted tree is called a binary tree if every internal vertex has at most 2 children, and if every internal vertex has exactly 2 children, then we say that a rooted tree is a full binary tree. For example, here suppose I consider this rooted tree, then here we can see that suppose I give labels V1, V2, V3, V4, V5 and V6. then we can say that V1 has 2 children, V2 has only 1 children, and V3 has 2 children. Therefore every internal vertex has at most 2 children, or every internal vertex has no more than 2 children. Therefore this is a example of binary tree. But it is not full binary tree because V2 is not having 2 children. A binary tree is a full binary tree is a rooted tree having exactly 2 children. So this is the definition of binary tree and m-ary tree, and we will use all these definitions in upcoming lectures, and we stop here. Thanks for watching.